Hey everyone, this is Nick. I'm working on a point-and-click survival horror game called Crabmeat, where you fish for crabs to pay off your debt to the feudal state. Now, today I want to show off a feature that I've been working on. Because the game is set mostly on this boat, we're really got a lot of detail in a very small space. As I've been working on the trailer and working on getting the game closer to release, very close now, I've been adding a lot of props and a lot of detailing to the ship. So as that's been going up, the performance has been getting worse and worse and worse. We have more unique materials, more unique meshes. The boat moves, the world stays still, which is traditional. It's how you normally would do things. And as a result, you can't use occlusion culling, you can't use static batching, and those methods just weren't going to work. There are some dynamic occlusion solutions out there, but all of them required a non-moving world, at least the ones I could find. So I needed to come up with a solution. Now, the keen-eyed among you might remember I posted a video a while back talking about occlusion for the lights. This was sort of a stopgap solution. This ended up being part of the solution to this problem, but turning off lights that weren't being seen by the player was one part of the puzzle. So, to break it down, we've got a boat, and the boat's not going to change, right? We're able to take that boat and break it up into multiple zones. We've got the deck, the upper deck rear, upper deck front. We've got the bridge, and even more detail, we go, like we say, bridge hallway, bridge, we call this like bridge ladder. The names don't really matter. It's just defining the zones. So once we've defined those zones, what we can do is we can assign every object that we want to cull, that be that a light or a prop in this case. Now we're extending that system to props, to one of those zones. We do that at edit time. We don't do that at runtime. It'd be a waste of performance. So I just have like a button. I'm going to go props, cache zones, and that just gets everything in the scene and assigns it the appropriate zone tag. Then at runtime, what we do is we need to evaluate which zones we should render. So collision on these zones is, let's look at one individual, right? So these are the triggers. That tells us, there's multiple triggers that represent one space. That tells us exactly where the player is in this moment, but that doesn't tell us what they can see. Now, frustum, looking at what's inside the frustum is not ideal, because when you are dealing with depth and things that have multiple layers, you could see a lot more than you actually need to see in terms of the frustum. So what we need to do is, some way, we say, oh, okay, this is behind, or this is not behind. The solution I came up with is fairly brute force and fairly simple. I actually just use the lights themselves to define, because we say, oh, the lights are in this zone. This light, for example, here, its light is flagged as being in the upper deck rear. So we could just say, oh, if we can see a light with line of sight, then we should render its zone. And then as soon as we just iterate through every light in the scene, and we say that zone is visible. And then at runtime, all the props and lights go, okay, which zones are visible from a set, and let's render those. The downside was that lights are not necessarily visible at all points, or, for example, if we say this hallway, there's a lot of times where this light, the things in this hallway are visible, but the light itself isn't. So I do some stuff like lights themselves. The trace point is actually like lower down from the light itself. So because a lot of lights are on the roof, so more often than not, we actually want it to be like somewhere between the light and the ground as the trace point. And then we also add extra conditions. So I have these like fake lights. For example, on the lower deck here, we've got one that sort of represents a halfway point between the mid deck and the lower deck. And that lets, because the lights in that room are still not going to be visible at some angles, there's got a lot of glancing angles that are not going to be visible. So let's get into the engine and actually play around at this and see what's happening. So right now, there is still popping with this solution. It's not perfect compared to what we had before, but what we had before was not perfect either. What we had before used the trace. It basically checked to see if it could collide with one of those zones, whereas we don't really use those collision zones for much at all. We really think about visibility of the object itself. We care about what we can see. But it's pretty good. There was an issue that, shout out to Dan Draper for helping with this. So, we would have some glancing angles. You can see the light popping in there, where the player could be right on the edge of a zone. So, for example, here, and because I was updating initially in update, not physics update, the boat would be moving in physics step. and things got out of sync, and if you were right on the edge of a zone, you would get flickering, where it would be like, on fixed update or update, it would be switching which one was visible. So that's been changed over to fixed update, and that seems to have mostly solved it. There is still popping, but the popping can be resolved by basically tuning the system, adding more proxy lights, better defining those zones, and breaking things up into more segments also improves things, because you sort of more incrementally can turn things on and off. So let's actually show, the thumbnail, what this culling is doing. Let's go into the cabin, and go in here, close the door, right? So logically, you're inside this room, nothing else really should be rendering. That's not completely true, because until I come up with a better way to do this, we still need to cull, we still need shadows. So if we turned off everything around the boat, we would not necessarily have a perfect solution. But you can see a lot of stuff is not rendering. The bridge is mostly empty. Everything in the hallway is mostly turned off. I haven't applied it to props yet, and I haven't applied it dynamic items. I also haven't applied it to some of these gameplay interactable objects, and that can be solved as well. And that'll be another performance win, having them not render at all times. But in general, this was a significant drop in our poly counts. So, jump back. So, let's turn on the old Unity stats drawer. Not a perfect representation for performance gauging, but it's useful. And you can turn the setting off if you have a mega machine. But you can see we're back up to 2.4 million triangles, 5,000, nearly 4.5 thousand batches. Turn it on, we're down to a million triangles with 1.2 thousand batches. So it really is a big win. This is a good example of like a worst case scenario. Actually, maybe I think slightly lower down is even worse. Maybe, yeah. Because you can sort of see the roof, you can sort of see inside the bridge. Because remember, we're thinking about this not what the player can see from a thruster perspective. Because lights can cast and things can cast shadows. We do need to actually render a lot more than what you can actually see on screen. But yeah, the player's head, sort of in an omnidirectional sense, can see a lot of things from here. So we do still need to render a lot of it. But generally, this does a much better job than what we have. Okay, and so for those interested in the code, the system is really quite simple. We're storing the states of each zone as a bool. It's funny, you can actually see these audio zones. It was originally built for turning on and off dynamic types of ambient audio. So initially, sound designer on the game, Mitchell Pasmans, we wanted to build a system for having different ambience in different regions of the boat. That was why we needed the system. So I had to actually sort of retrofit all three things together. So now we have the audio and the visibility sort of in the same space, because they are kind of the same thing. The only difference is audio only cares about what room we're exactly in, whereas visibility is omnidirectional. But yeah, we store each zone as a bool, and when we're iterating through the zones in our trace, we're turning them all off initially. If we're not doing culling, we just turn them all back on. We're dealing with bools, so this is all very cheap. We cast them to an int for anything that's the highest zone, so this is the one that's using collision. That's the one we're standing in. Our collider is inside that zone. If our map is enabled or our security cameras on the boat, we need to render whatever that security camera can see, so they can push on a visible zone. Things like the door, we actually let the door push on a zone as well, so brief for like about a second as you pass through a door. The second you hit that door, it says, hey, that zone in front of me is going to need to be visible, so let's push that on for a little bit as well. And then this is the primary bulk of it. So any zone, we go through every light in the boat. Not, again, like I said, brute force. Any light that's maybe wants to skip itself can skip itself. If the light is in a zone that is already enabled, we don't need to check it. So let's just skip those altogether. So that usually cuts through quite a lot, actually. And then we can turn on and off async or non-async checks. This is basically the difference between doing a physics update in runtime or one frame behind using the Unity job system, running through util that... actually, no, I did not write it. It was written by Dan Draper as well. Or maybe Geordie wrote it for Justice Sucks. It went into Killbug, a game I worked on before, and then I used it very extensively in Killbug. So this is a system for submitting requests to a job batch, basically, and then our manager sends off all those requests at the end of the frame, and then the next frame we get the results back. So everything you're getting is one frame behind. But it's much, much faster than doing them synchronously using that. So I have this little flag here so I can turn them on and off and see which one's faster. Still haven't actually decided which one I'm going to go with for ship. And that's basically it. Like, we just determined, do we have line of sight? If we have line of sight, we always turn on the lights. And then props, we only turn them on if the zone is in front of us, approximately. And again, we have to go through every light again to see if it's the right type. And then we need to go through and check if it's in front. As soon as we have one that's in front, we call it good enough. And that's basically how it works. Okay, thank you for watching. Please wishlist the game. The demo is coming out very soon. So it'll either be out by the time you watch this, or it'll be like days away from being out. So check that out. And I hope you enjoy the game when it comes out. Bye-bye.